Now, you've got a block hanging from a spring. It's pulled down 10 centimeters and released. It bounces up and down at a rate of 3 times per second, 3 hertz. You want that rate to be increased, maybe to 4 hertz. Which of these things in the list, or maybe something else that you can think of, could you do to make that happen? Talk to your neighbor. Which of these things would increase the frequency?
So increase the frequency, decrease the mass?
Yeah, that's what I was thinking, make it go faster.
Yep. How about push it faster?
You could, I was thinking also you could make the string stiffer so that way it's got less momentum.
Okay, brave soul, where are you? Raise your hand. Which would you do?
I picked 3.
Which 3?
Increase the mass, make the spring stiffer, and not pull it down as far.
And not pull it down as far. So you'd pick this one, and this one.
Yes.
Okay? Anyone have a different answer? Yes, sir.
I would take the pulling it down farther out of that list.
So you think it's only 2 things?
Yeah.
Okay. Let's test that out. You both agree on these 2, right? Decrease the mass and make the spring stiffer. Let's see about pulling it down further or less far. If I pull it down a little bit, boing, boing, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now if I pull it down further, 1, 2, 3, 4, 5, 6, 7. It's the same rate. That's the simple in simple harmonic motion. Simple harmonic motion will never, and by that I mean never, depend on the amplitude. Never. Ever. Now why? I don't know. That's just the way the world works. We have no right to expect that. It simplifies the mathematics immensely. It also gives us a lot of rich behavior that has caused bridges to fall down, called resonance. Okay? And that principle is that simple harmonic motion of an oscillator only depends on 2 things. It depends on how stiff the spring is, or whatever restoring force you have in the problem. Whatever's acting like a spring. And it depends on how hard it is to move the system, how much inertia there is in the system. In this case, the mass of the block. Now, it's always independent of the starting conditions and the amplitude of the motion. In other words, it doesn't matter whether I pull it down and release it from rest, 1, 2, 3, 4, or whether I start it by hitting it. 1, 2, 3, 4. I get the same frequency regardless. Now we can do a lot of fancy math and derive this formula, but it's going to take a lot of time. Instead, let me just give you the result. The period depends on the mass of the block and the spring constant of the spring in this way. And since we know that the frequency is just 1 over the period, we also have this formula. And those will be on the front page of your midterm.